This chef is going out to do some chemical reactions. Your sausages barbecue better if you understand some chemistry. Burning any fuel is a chemical reaction. But is he using the right fuel? Something's cooking, but it's not his sausages. The fuel next door seems to be working okay. Is it something to do with the energy produced by the chemical reaction? The world is full of chemical reactions. The hardening of glue, for instance. And the making of toast. Boiling water is not a chemical reaction because the water isn't really changed. But poaching an egg is a chemical reaction because the egg is changed. And like many chemical reactions, this one is irreversible. You can't unpoach an egg. Many chemical reactions produce an energy change. This one generates a lot of sound energy. And this reaction generates light energy. Easily enough to read by. Here's a reaction that seems to generate cold. Dissolving this chemical lowers the temperature of the water. But you can't make cold. In fact, the process of solution absorbs heat from the water, which is why the temperature falls. And now a reaction that generates heat. When the welders want to join on a new section of railway line, they use chemistry to do it. First, they pack sand round the space they want to fill with the steel weld. Then they fill the hopper above with thermite powder, a mixture of iron oxide and aluminium. After heating up the ends of the rails underneath, they start the reaction with a giant sparkler. And stand back. So much heat energy is produced that white-hot liquid steel runs out at 3,000 degrees Celsius. It fills the space between the ends of the rails and welds them together. They have to trim off the extra steel and grind down the surface, and the railway lines are permanently joined together by the power of chemistry. What do you get if you put toast in a toaster? Burnt toast. You can show what's happening using symbols. Bread goes to toast, goes to burnt toast. What happens to the mass of a piece of toast when you burn it?
And give it to Robert to be weighed. The weight is, Robert?
6.20 grams.
Shivana, 6.20 grams. Well, we're going to burn the toast, and I predict that this piece of toast will increase on weight.
The weight will decrease because as it gets hotter, it just gets smaller and smaller, and it goes, and then it's so light that it can float into the air. I think it'll turn into carbon dioxide.
I think it will increase. The weight will increase a lot.
What do you think? Go on, make a prediction. Will it weigh more or less than it did before? Before burning, it weighed 6.20 grams. Now it weighs 4.52 grams.
4.52 grams.
Where has the mass gone? What do you think will happen to the mass if you burn a piece of toast in a closed container? The mass of the container plus the toast is 22.2781 grams. The mass of the container plus the burnt toast plus the smoke is exactly the same. Is this a fluke? Or does the total mass always stay the same in a chemical reaction? Remember the barbecues? Is this the right fuel for the job? The man next door is using a different sort of fuel. For hundreds of years, the most important fuel has been coal. Coal is mainly carbon, and scientists give carbon the symbol C. When it burns, carbon reacts with oxygen in the air to form carbon dioxide, or CO2. This is the chemical equation for the reaction. fuels produce carbon dioxide when they burn. Unfortunately, some fuels produce other oxides as well, because they aren't pure carbon. What sorts of problems might these other oxides cause? This scientist is trying an experiment. He's testing his theory that a firework let off underwater will make the water turn acid. Lots of gases are produced in this chemical reaction, and most of them are acidic.
Two or three drops.
The team want to find out what other things produce acidic gases when they burn. Their plan is to burn things under a funnel and pump the product gases up the tube and through this water trap where they've put some universal indicator. Burning coal produces lots of black smoke, and the products are slightly acid.
Yes, my prediction was right. This has got acid and it's turned slightly red.
One reason is that there's a little bit of sulphur in the coal, and when you burn sulphur, the oxide is very acidic.
Oh, it's unfair, hasn't it? It's not right. They're not yellow. Oh, no.
One answer is to take the sulphur out of the coal before it's burned. These cast iron tubes are like giant test tubes 6 feet long. In the plant, they stand upright in racks below these lids. Heating the coal in the tubes drives off the sulphur and other chemicals that produce acidic oxides. The people who work there wear special protective helmets. There's a little fan that pulls air in at the back, blows it through 2 filters and down at the front, so they always have clean air to breathe. The coal goes in at the top, is heated at 640 degrees Celsius for 4 hours, and comes out at the bottom as a smokeless fuel. They don't waste the chemicals that have been driven off. Among the byproducts are ammonia, which is turned into fertilizer, and phenols, which are converted into cheap perfumes and E-numbers. Expensive perfumes are mostly natural products. But what other things can you buy in the chemist that are made, by chemistry, from simple raw materials? There are lots of chemical reactions going on in these cars. and they produce a lot of acidic oxides. When a car goes for an MOT test, they start the chemical reactions going, and then check the exhaust gases for carbon monoxide and unburnt hydrocarbons. There's also another nasty reaction going on. Nitrogen and oxygen from the air react to make a mixture of oxides, commonly known as NOx. This cylinder contains hydrogen gas, a fuel that produces lots of heat and almost no pollution. Could it be the fuel of the future? It's much lighter than air. When hydrogen burns, the flame is so clear that it's hard to see. And the product is our old friend H2O, or water. The hydrogen flame is so hot that it will easily melt copper, which is almost impossible to do over a Bunsen. When it's mixed with oxygen, hydrogen makes an explosive mixture, but the product is only water. Could you run cars on gas? Well, it's been done in the past when they thought that coal gas was the answer to all their problems. With a balloon full of coal gas on the roof, who needed petrol in the tank? And today, a German car manufacturer thinks that hydrogen might be the fuel of the future, though they put a cylinder in the boot. You can make hydrogen by electrolysis. An electric current passed through water turns it back into hydrogen and oxygen. But this does take a lot of electricity. That's fine if you live in the desert where there's plenty of sun, because you can collect the sunlight and generate electricity. But most people have to make electricity by using chemical reactions. What are these reactions? And what problems might they cause?